Alright, welcome to the video on 12.1, tangent lines. We're going to be looking at a brand new vocab word, which is tangent, not the same tangent as when we did SOHCAHTOA. We're going to look at what happens when a line is tangent to a circle. So what that means here first, a line is tangent to a circle if that line is intersecting the circle in exactly one point. It only hits the circle once. So this red line over here is coming along. It's not touching the circle, still not touching the circle. Right there at point B, we have something called a point of tangency. At that point, the line and the circle are skimming right there. That's where they're in contact. As soon as I'm a little bit lower than B, I'm not on the circle anymore. And then forever and ever, I'm going to get further and further away from that circle. So tangent is only going to hit once. It's going to go through, just barely touch the circle in one spot, and then move on. So the essential understanding of radius of a circle and the tangent that intersects the endpoint of that circle, so the point of tangency, have a special relationship. All right, so here's the special relationship between the point of tangency and the radius. If a line is tangent to the circle, it's going to be perpendicular to the radius. Alright, so it's only going to hit it at one spot. Here's the radius of my circle. Here's my tangent line. What this theorem is saying, theorem 12.1, is where the red line and the radius meet, it's going to have to be at 90 degrees. Alright, so we're going to use that to solve a few problems here right away. Alright, I know that if it's a tangent, it definitely 100%, it's a certainty that it will be a 90-degree angle where they meet. So, using that information, this one says ML and MN are tangent to circle O. So that's going to be the information that we need. They want the value of x, which is this angle right over here. Here's what I know. ML is a tangent line, which means if this is a radius, I have 90 degrees right there. I know that MN is a tangent line, meaning if this is a radius, I have 90 degrees right there. So I have two 90s, a 117, and an x. So I can use that information to find that missing angle, because if I know that this is a quadrilateral, I know that this has a total of 360 degrees inside. So here's what I know. I know that all four of those angles add up to 360. All right, I have an x, I have two 90s, because I have two tangent lines, and then 117 on top of that. I can just solve this like we've been doing all year. So 360 then is equal to x. When I add up 90, 90, and 117, I get 297. So all I need to do is subtract 297 from each side and end up with my answer. All right, x will be 63 degrees, which on mine is multiple choice. I don't think it is on your note packet, but 63 is that answer. Okay. This one, we only have one tangent line, but it's a triangle, so we have a different total as well. I know that ED is a tangent line, so I'll find that line. I know that that's tangent to a radius or a diameter, which means I have a 90, it's a right triangle, okay? Triangles add up to 180, so it's going to be the same exact situation. I know that 180 is the total. That's equal to x plus 90, because I have one tangent line, plus 38. So in other words, 180 is equal to x plus 128, and then subtract 128. Simple as that. So x this time would have to be 52 degrees. Okay? So if there's a tangent line, it touches the circle once, it touches right at the radius, all right, or at a radius, and it's going to be 90 degrees to that radius. Okay? We can also use tangents to find length. So these ones, make sure you take really good notes. Kind of a more challenging question here right away. This one says, the CN Tower in Toronto, Canada has an observation deck 447 meters above ground level. About how far is it from the observation deck to the horizon? So this is the question. How far can I see? All right. It'll tell me what Earth's radius is in kilometers, about 6,400. Alright, so here's what I know. Here's the surface of the Earth. This is how tall the tower is, this blue point. That's the tower sticking above the surface of the Earth. Okay? they want to know how far could the eye see from that point. So your sight of your eye line until you see the horizon, what you're seeing when you see the horizon is really that tangent point where you can't see anymore because of the curvature of the earth. So I want to know how long that line is. Okay, that's what I want to see. How far can I see in kilometers? So they did do some rounding. They turned 447 into 0.45, but that's okay. I know that the radius is 6,400, so from the surface to the center of the earth, that's 6,400, and then this is 6,400 more. All right, so this is going to be a Pythagorean Theorem problem, and let me just redraw the triangle. We can use Pythagorean Theorem like this. I want to know how far I can see. This is my hypotenuse to the center of the earth. I know that this distance is 6,400. That's my right angle. I know that this is 6,400 plus the height of the tower. So 6,400 plus that 0.45. We're just going to call it 6,400.45. Okay? We're going to use Pythagorean Theorem on this. So if I can use right triangles, I can figure out how far I can see if I'm on the observation deck of that tower. So x squared plus 6,400 squared will give me 6,400.45 squared. All right, so we're going to get a little bit larger numbers here, but that's all right. We have x squared plus 6,400 squared would be 40,960,000. Okay, that's equal to 6,400.45 squared. So this is also 40 million, but it's going to be a little bit bigger. 965,760.2025. Okay, so that's what we have for our just square step. We need to subtract 40,960,000 from both sides. Okay, whatever we do to one side, do to the other. Okay, we're left with x squared equal to, on this side, we did our 40,965,000 minus 40,960,000. What's left is 5,760.2025. We're just going to take the square root of that. What we'll get is our answer in kilometers of how far we can see from that point. So the square root of that is about 75.896, which we'll just say is approximately 76. So from that tower, you can see about 76 kilometers until the curvature of the earth makes that horizon for you. Okay? We'll try that again. A similar setup here. This one says, what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the earth? Okay, and then we're in miles this time, so they have to give us a new radius. So we're in a plane above the earth. So we're 2 miles above the earth. Okay, we want to know how far can we see. That's a tangent line. Okay, a little bit messed up picture there. Okay, so from this to how far can we see? Okay, this is the x. Okay, we need to think about that this is a right angle. All right, so we know that the radius of the earth is approximately 4,000. So this is 4,000 and this is 4,000. So that means, again, we would have to add those together. Let's redraw the triangle. All right, we have a triangle with x and 4,000. Those are my legs. All right, the hypotenuse is 4,002. All right, we're 2 miles above that surface. So we're going to set up our Pythagorean Theorem. We have x squared plus 4,000 squared equal to 4,002 squared. Okay, so we're going to go through all this again. So x squared, 4,000 squared would be 16 million. That's equal to 4,002 squared, which is 16,016,004. Okay? When we subtract those two, we get just that 16,000 and change piece. So we have x squared equal to 16,004. When we take the square root of both sides, we get our answer. X is about the square root of 16,004, 126.5 miles. That's how far you can see if you're 2 miles above the Earth on a clear day. All right, so that's going to be one main skill that you might need to do. Okay, there's going to be a couple other different ideas that are couple properties of tangents that we also need to know. All right, so we'll go through one more on this video, and then we'll switch to the other one. Okay, this one says this: if a line in the plane of a circle is perpendicular to the radius, then we know it's a tangent. Okay. So it says if a line in the plane of a circle is perpendicular to its point, then it's a tangent. So what it's saying is if I see that right angle there, I know this has to be a tangent. That's what this one's saying. Okay? So I know that I have tangent lines. All right? So there's a couple problems that we could get from that. All right? This one has a little bit of a tricky bit of algebra for what we have here. So this one's asking, what is the radius of the circle to the right? They're asking this. I see a right angle here, so I know that AB is a tangent line. Okay? I have a right triangle then, all right, with a couple radiuses that are left out. They just call them x instead of actually giving me the length. So I need to find out that value of x. So here's what I have. I have Pythagorean Theorem again. I know that the legs are x and 12, so x squared plus 12 squared equals that hypotenuse squared. So we have to be careful. The hypotenuse total is x plus 8. A lot of times people will write 8x right there, but we want x plus 8. So we have x squared plus 12 squared equals x plus 8 squared. All right? And we have to be really careful with the algebra here. So we have x squared, 12 squared is 144. When we square this side, it's not just distributive property. We can't just distribute the 2 into both. What this means, this squared means, is that there are 2 x plus 8s. So we need to remember how to FOIL. This is a FOIL problem, okay? When you have a set of parentheses squared, it means there are 2 sets of that parentheses. All right, so we have x squared and 144. All right, we need to FOIL. So first time first is x squared. Then you have your outsides, 8 times x. Then you have your insides, another 8 times x. Then you have your last 8 times 8, 64. Okay, so we're getting there. We're almost there. All right, what we need to do now is take and just combine a couple like terms. We have 2 8x's here in the middle that are just going to make 16x. And then we have something to solve here. So anytime we have to solve something with a squared in it, you get worried. We might have to factor or quadratic formula or something like that. Okay, that's not the case this time. When I take and start trying to get everything on one side, all the letters on one side, if I subtract x squared from both sides, they're going to cancel out this time. Okay, so then at that point, it's just a linear solve. So I want all the letters on one side, all the numbers on the other. So I'm also going to move this 64 over here. All right, what I end up with is 80 on this side and 16x over here. Okay, all I have to do at that point then is divide by 16. So this is a total of 5. So I know that 5 is equal to x, which is that radius. Okay. At that point, we're going to try another one. All right. So with the next problem, the steps are the same. If you do it right, you should get a decimal. You should try that next one. All right, and then go to the next video to see if you have it right. Okay. So that'll wrap up the first part of the 12-1 notes. Alright, so you might have already tried this a second example at the bottom of that page, but let's look at one just so that we can see the process again. When you're looking for the radius, you're looking for how far from the outside to the center. Alright, with these problems, if you know that we have a right angle here, that means that 10 is a tangent line. I can use Pythagorean Theorem to try to set this up. I can say that x squared plus 10 squared equals parentheses. Remember, we have to combine those two and call it x plus 6. So we could say that's x plus 6 squared, which really means that what we're looking at doing is foiling x plus 6 times x plus 6. So if you do these right, they should work out where after you FOIL, you end up with the x squareds just dropping out. I could subtract both sides by x squared, and then those are gone. Okay, so then I could subtract each side by 36. All right, and I'll continue over here. Then I would have 64 equal to 12x, and dividing by 12 will give me my final answer. X will be about 5.33 this time. So you'll try some of those FOIL ones on the homework. With those, just make sure that you remember to set up x plus 6 instead of x times 6. All right, one other type of question you'll get with that theorem is looking at whether or not something is tangent. So this time they want to know, is ML tangent to circle N at L? So they want to know, is this a tangent line? Well, they're asking if that's a right angle right there. So we have talked about how we can decide if it's a right angle or not. We just say, does Pythagorean theorem work for that problem or not? So really what they're asking, we want to know, is angle L a right angle? That's really what they're asking. So the way we can check is with the converse of the Pythagorean theorem. 7 squared plus 24 squared equal to 25 squared. So I usually just put a little question mark above the equal sign. Okay, that's what we're going to check. So 7 squared, that would give us 49. 24 squared is 576. 25 squared is 625. If you add together 49 and 576, you get 625. So since they're both 625, we can say that yes, ML is tangent to circle N at L. And we already kind of explained by showing our work. Okay, so try that again. There's no picture for that next one. But if NL is 4, ML is 7, and NM is 8, is MN tangent to circle N at L? So give that one a shot. See if Pythagorean theorem works for 4, 7, and 8. And then we'll resume after you've checked. So for this one, you should have the answer already. But what we're checking is whether 4 squared and 7 squared add up to 8 squared. So if 16 and 49 make 64, well, this time 16 and 49 make 65, which is obviously not equal to 64. So no, we do not have a tangent line for that one. Okay, so if you get a question like that, that's what we're looking to do. Okay, last idea here is one last theorem. It says if two tangent segments, so now if you have two of them, if they share a common endpoint, then that means that the two segments are congruent. So if you have two tangents that both start out here at B, the distance from B to A is the same as the distance from B to C. So if you see them start in the same spot outside the circle, that means that they're the same length. So you might get a perimeter type question based off of that. So this one says circle O is inscribed in triangle ABC. We want to know what is the perimeter of the triangle ABC. All right, so for the perimeter, I have to figure out a couple things. So here's what I see. A to D should be the same length as A to F. That should be a 10. And C goes to F, but it also goes to E. These should both be 8s. B goes to D, 15, so it should also go over here, 15. So really, it's just about adding all that up. The perimeter, we have 2 10s, we have 2 15s, we have 2 8s. Okay, so that's what we're looking to do here. So we have 10 plus 10 plus 15 plus 15 plus 8 plus 8. The perimeter of that triangle is 66 centimeters. Again, if you see two tangents start from the same spot outside the circle, that means they're the same length. Okay, so try that process again for this one. Again, we'll resume the video after you've looked at it. So get this one set up as far as you can. So this one's looking for something a little bit different. If you've already tried it, then you can tell. They're asking for what is the length of QY, which I have on the picture as green already. They're asking for this length of QY, all right, which is the same as the length of QX. So if you look at adding all this stuff up again, they gave us one extra piece of information. They told us the perimeter already, all right? So we know the perimeter is 88. So we know that 88 equals 2 15s, 2 17s, and then 2 x's. All right, we're looking for that QX or QY, which is the same as QX. All right, so if we combine all the numbers we know, we get 64, and then we have 2 x's to deal with. Okay, which means if I subtract 64 from both sides and divide by 2, I can get to my answer. So I have 24 equal to 2x, or QY must be the length of x, which is 12. So QY, to answer the question, is 12 centimeters. All right, looking at those perimeter problems. Okay, one last check to make sure that you've picked up everything we need for this note section. All right, you can work through these 3 here. So feel free to try to pause and work ahead of me a little bit. If using measure of angle A is 58, what is the measure of angle ACB? So I see a right angle right here, which tells me I have a tangent line. All right, if A is 58, then remember, if it's a triangle, all 3 angles have to add up to 180. So I have a 90 from the tangent, a 58, and an x. So really I have 180 equal to 148 plus x. When I subtract 48 from both sides, x is going to have to be 32, or 32 degrees. Okay? If BC is 8 and DC is 4, so if B to C is 8 and D to C is 4, what is the radius? They want the radius, which is also the radius here. So the hypotenuse has a length of r plus 4. So this is going to be a FOIL problem with Pythagorean Theorem. We have r squared plus 8 squared equal to r plus 4 parentheses squared. Okay? So we have r squared in 64 equal to r plus 4 times r plus 4, which means we have, once we FOIL, r squared plus 64 equal to r squared plus 8r plus 16. The r's will drop right out of that when we subtract by r squared. If we subtract 16, we have 48. So 48 is equal to 8r. When we divide by 8, r equals 6. Okay. Last one. This one's not going to be a FOIL problem. This one's just back to normal. So if I change the numbers a bit, this one's saying if AC is 12 and BC is 9, what is the radius? So now they want this radius here. So this one, a little bit easier because they gave us that entire side length. We have r squared plus 9 squared equal to 12 squared. And then from there, we just have r squared plus 81 equal to 144. Subtract 81 from both sides. We have r squared equal to 63, and we take the square root. So that should be really close to 7.9 if you go to that calculator, and then that would be your final answer. Okay, so with tangents, that's what we're looking to do. They could either be problems with Pythagorean Theorem, maybe some foiling in there. There might just be some angle sum theorem, or maybe a couple perimeter problems. So as you go to the worksheet, I think you're set up for success now. So go ahead and start trying out a few problems on your own.